This is Autodesk TinkerCAD. You might have seen this side before. There's just the modelling. And what we're going to do is we're going to look at the circuit side. So if you just click circuits and then click new, and we're going to click a new circuit. Now it's fairly straightforward and self-explanatory, but I'll just go over some of the rules for breadboards really and how to simulate stuff. So I'm going to drag the breadboard in. Now, if you looked earlier on the theory notes, you can actually see that these columns here, they're all connected, okay? And they're all connected, but they're not connected to each other because of this groove. And the power rail is connected, and the power rail is connected, and as are these and these, but this obviously is not connected to this. Now, if you've got a real breadboard and it's larger, which are normally about that, you will also notice that there's a gap here. And just to be sure, these are actually separated in the real one. So if you wanted to connect them, you would normally have to just draw a wire, or not draw a wire, sorry, create a wire, put a wire from there to there. Now obviously it doesn't really matter what colour you choose, but normally we try to keep the negative black and the positive red. And if you chose to do it different colours, for example, if I did that one green, then even though you may understand it because you're working on it, when it comes time to checking or asking for help, that other person's going to find it quite difficult. So we do try and conform to the standards. But of course, the colour of the wire means nothing to the way it works. Okay, so I think I'm showing you how to do a parallel circuit in this one. So what I'm going to do is I'm going to take my supply, my voltage, and I'm just going to spin that round so that the plus is here and the negative is there, and I'm actually going to make that positive and that negative. Again, you can do whatever you want, but it's just the way that I prefer to work, so I'll do that. And now I know that ground or negative is all at the bottom, and of course now I know that the power red is all the way at the top. And yes, I could put it in there and it would still work, but of course you're not conforming to standards, and then someone else who's trying to check it is going to have a hard time. Okay, so in this one I'll do a series and a parallel just to show you how it works. Now if we bring the LED, you can see that we've got some of the data there. We've got the flat side there, which is the cathode, that's the negative side, and we've got the positive side there. And again, you're quite welcome to turn it round if it makes your life easier. And so I'll actually do it like this now. Alright, so I'm just going to press escape and I'm just going to drag that in. Now if I push it like that, it means that the anode and the cathode, or the positive and negative of the LED, are connecting. So would that work? Well, why don't we just find out and see. So I'm going to go from here to here, and then I press escape so that so it doesn't turn itself black, and I'm going to go from here all the way to here. So what I've effectively done, many of you would have already seen it, is the red wire is coming in, it's connecting to that whole track. This doesn't mean anything because it's all connecting, and it's going straight to ground. And of course it's just going to do exactly what it normally does, and that is get to ground as quickly as possible, and it's not even going to hit the LED at all. Okay, so that's why we normally have things pointing up, even though it's a little bit more challenging to see. I'm just going to take that out. Okay, so now I've got the cathode there, the anode there. I can of course mirror it, so I'm actually going to put that in, and I'm going to take that wire and just redraw that. Okay, so we'll just go black and we'll go down all the way like that. Okay, well I've got 9 bolts on a component that only requires 2 volts. So what's going to happen? Oh, there you go, you've fried your LED. Okay, so this is basically just proving the need for that resistor. And there's the resistor, it's coming through. Now you've already hopefully done your calculation. So I'm just going to put in 470, make sure your multiples are correct. And so my 470 ohm resistor is going in there. And now I'm just going to put that through like that and then simulate. And there, I've got power. Okay, and you can turn that off. Now I could always put a switch on it. Now these switches, it's very similar to micro switches. If I do this, we need to find out exactly which one is being connected. Okay, is it bit 1B to 1A, or is it 1B to 2B? We don't know. Now, of course, as you become more familiar with these sort of components, it's going to be a bit easier. So why don't I take this wire here and just put it there, and I'm going to take another colour and I'm going to put it here. Okay, and I'm going to go to resistance, which is there, and I'm going to start the sim. Okay, so what I've got there is absolute infinite resistance, and then when I push that, there's no resistance. What that means is this switch connects 1B to 2B. Okay, well, we better prove it. So I'm going to take this wire and just put it here, and just move that out of the way so you can see that they're not touching. Okay, and we'll just start that simulation again. And now when I push the button, nothing changes. So anything going here to here will connect to here and here on that. Okay, just stop that, and let's just do this one. Oh. I'm just going to put it here. Okay, start that simulation again. So infinite resistance, and so there you go. So this would be a single pole, single throw, so what that means is this is connecting these two to these two, but these two are already connected together, so it's not two separate switches. Alright, well, I can delete that, I can delete that, I can move that there, just keep that there. I'll delete this one. I'm going to put a switch in here, push this up there, and then it's going to be confusing, isn't it? I'll tell you what, let's make it a little bit neater. So we'll do that. Okay, and now what I'm going to do is take this wire here, and I'm just going to take that wire and put it to that wire there, and there to there. Now theoretically, if I've done it correctly, nothing should happen. Okay, so it's simulating, you can see the time's ticking, and if I click that, and that's how you use your switch. Okay, so this is your momentary switch, and I'll show you the slide switches now. Alright, so here we've only got one input, one output, okay, or two contacts. Let's get rid of that. So let's put that one in here. Alright, now in the theory, you should know that this and this do not connect, and they never connect. This connects to that, and that connects to that, and this does not connect to both things at the same time. Alright, so what I'm going to do is I'm just going to put that there, and I'm going to actually, sorry, I'm going to delete that. Just move that there, it's a bit fiddly, isn't it? Okay, and that's going there. Now I like to practice putting anything coming from the positive to the common, but it doesn't matter, the common is the middle. Alright, well, let's find out what that works. Okay, so it's on, and if I click it, that's going to click it off. Okay, so what's the point? Well, that means that I can actually have two circuits. So we'll do that and we'll make it green, and we will just do a red wire coming all the way down from there and going up there. So now I've got my positive going to the anode, and now I need the resistor again. So different colour LEDs do actually require different resistance, but for now we will just copy and paste it. So it's coming there, going down there, and I want this to go to here, right, and just see if I've done it right. Okay, so that's on that one, and of course that's on that one. Alright, so that's how that switch works. Alright, so that is a series. We're not in parallel yet. If I was to do parallel, let's see if I can do it without moving anything. Just going to flip that. Okay, so the way the parallel works is the positives coming in and going there, and of course because that is on the same column, that and that are connected. And now I am going to draw a black wire that is from that side coming out, and of course it doesn't matter whereabouts that wire is, so that's there. And now if I bring my resistor here, it means that the power is going through both LEDs, then down to ground, and then through the switch. And theoretically, if I do that, we should get both. Okay, so that would be your parallel circuit, and that's how breadboards work, and they work on simulation as they do in real life. Now, this is the cool thing. We can actually stop that simulation, and we can go here. Now this is schematic view. Now the schematic view in TinkerCAD is a little bit wild, as in they do lots and lots of crossing over stuff, and you can't organise that, I don't think. But the symbols are there, so it's quite a good idea to screenshot your circuits and show what you've been doing.